This illustration deals with available fault current, as defined in NEC Article 100. The purpose of change, this new definition has been added to address fault current. The new definition defines fault current as the current delivered at a point on the electrical system during a short circuit condition. This new definition is based upon the results of an NEC Correlating Committee task group that reviewed the use of the terms fault current, short circuit current, available short circuit current, etc. So they wanted to make sure that these definitions were used properly throughout the code where they would appear. And used to, fault current was defined in 250.2 and it was moved over in the 2017 edition to Article 100. Now, before we kind of get into this, you have to have a low impedance path to get fault current back to the transformer or short circuit current, whatever it may be. Now, notice if we review from the circuit breaker and the panel board, where it says overcurrent protection device with interrupting rating, then notice that equipment ground, as we pointed out in the previous illustration, the equipment ground, if used, had to be sized from table 250.122 based upon the overcurrent device. And we just said, for example, if you had a 200 amp overcurrent device here, then I believe our table 250.122 would require number 6 equipment ground if used. Now, the grounded conductor that's routed from the grounded bar and the panel board back to the transformer now. We don't have an overcurrent device head of that transformer. So we would review the size of the conductors and say they were 4 terminating to, say, a 225 amp main. Now, we'll just give an example here. Then the 4 from table 250.102C1 would have to be at least a number 2. But you have to compare if it's neutral current involved. And naturally, you would go to 220.61, calculate the neutral load, and you can say, well, yeah, we come up with a 1-aught, 150 amp neutral load. Then you would have to increase from number 2 from table 250.102 C1 to the 1-aught conductor calculated for a neutral from 220.61 to have that low impedance path. Now, first, I would like to kind of call out the electrical equipment. That is the point of fault, as you see there. And the fault occurred in panel due to short circuit current. So somebody was working right there in that electrical equipment, and a ground fault occurred in some manner, or a short circuit, whatever it may be. And we've talked about how we'd have a low impedance path all the way back to the transformer, what tables would regulate that. Now, secondly, the maximum term that's used in the definition was deleted, so it's not in there. Now, as a reminder, available short circuit current, we would see 110.24, and it states at the service equipment, you have to calculate the amount of short circuit current would be there under normal operating conditions if you didn't know other conditions exist. That's 110.24 of the NEC. And then we have a figure that points this out as figure 100.1 in that informational note. And then notice if you was working in a transformer, boy, it's very high. The conductors would reduce it to say to the panel, if you're working in there, it's going to be lower than what it would be here. But say that you had 10 Ka breakers, then your short circuit current would be 8,500 amps there, then that 10 Ka would interrupt it, and that's what they're talking about, to make sure your breaker, 10 Ka, 22 Ka, 30 Ka, whatever it is capable of interrupting the available short circuit current that could be delivered to that point. But this basically says wherever you're working, pull boxes, junction boxes, whatever, the available short circuit current there can be very dangerous. And 70E says some of these old breakers, in accordance with 70B, chapter 17, those old circuit breakers can may not clear an 8 to 9 cycle, and you think about that. That means that available short circuit current at that one point, it's going to take 9 cycles before it will ever clear. And basically 70E says take the cycles, if it was 9 cycles, multiply it by 0.0167, and that would give you the clearing times in seconds. So we like these circuit breakers to clear in about 2 cycles or less, and so we kind of comply with 70E and 70B.